it makes more sense to not write H2O and to write water as HOH. Now, one thing we would have learned in the reaction section is that when you've got an area that has a double bond like this, you can break it, and then each of these carbons ends up being a spot where you can put something. And specifically what we're going to put is we're going to put a hydrogen on one of those, and we're going to take the OH and we're going to attach it to the other carbon there. And that's exactly what I'm going to do. So I'm going to break that double bond. We'll change it into a single bond. And then on one side of our molecule, we'll put the OH. I leave myself a lot of room, but I'll put the OH right there. That's the pink OH. And then on the other side here, I'll put our hydrogen. That's that one. And then let's not forget about those other hydrogens that we have surrounding. So these hydrogens here, they're not doing anything. We're just going to rewrite them. So those have stayed the same. So I know with all my colors here, it might be a little difficult to see, but that thing we put on the end, it is now an alcohol. It has an OH group attached to it, and that's what makes it an alcohol. Something was said. Nothing was said. Okay, so what happened here? Okay, so let's just talk about what we made here. So, an alcohol has been created. It's that OH group that we talked a lot about the OH and the base, acid base unit. That's the OH, that's the basic thing. So I guess alcohol would be basic if you tested it. Now there's a general form, so we got to get kind of used to these general forms. Hopefully it's not too confusing. So here is the general form of an alcohol. What you do is you write an R, and that R represents all the hydrocarbon stuff. I'll write that in a second. So you can take a few carbons, and as long as you bond it to an OH somewhere, that is what an alcohol is. So that R stands for carbons and hydrogens. And it could be any length. So that R could just generally represent maybe we have one carbon, or maybe we have two carbons, or maybe we have three carbons. I don't know. Just kind of goes on and on like that. So it's just a general form. You'll see that in notes. We're always going to have a general form for every one of these. Again, so the general form of an alcohol is you got an OH attached to a bunch of carbons. And instead of writing the bunch of carbons here, we're just writing R. That's it. So we can, well, I don't know, why don't we just look at sort of the simplest ones, and then I'll show you the name, and I think you'll catch on. The naming here is pretty straightforward. Any questions about that? Okay, cool. So I'm going to draw the most simple one that I can think of, which is one carbon. So one of these bonds has to be an OH. Doesn't matter where we put it because we could turn our molecule. So there's your first one. You could write CH3OH if you wanted. I don't care. Here, I'll just put that as well. So CH3, I condense that down, and then OH. Whichever one you want to write is absolutely fine. Now, our naming system is very similar to stuff we've done before. So we've got one carbon here, right? We've got one carbon. We're talking about a meth. So if you want to name this one, you would name it, that's supposed to be an M. In fact, you put the A as well and the N. The only thing that's different is the E is now gone. It's not methane. It's now methanol, just like alcohols. Okay? So the this part here, alcohol, is now there. Methanol is your simplest one. So 2 carbons, CH3, CH2, OH. That's your next one. I think I prefer to write it condensed, frankly. It's got 2 carbons, so we'll call this one ethanol. Again, that because of that OH, we change the ending. When we get up to propanol, we actually have 2 versions of propanol. Okay, so we actually have a couple of isomers. Again, isomers, compounds that have the same formula, but are drawn differently here. So let me show you both of those. So let's draw our 3 carbons, and here's what we're going to do. We're going to put the OH off that group, and then as well, I'm going to draw it with the OH in the middle spot. And I'll fill those hydrogens in momentarily. Okay, so same idea would happen. That's weird. Same idea would happen if we were to number our carbon chain. So that would be the first carbon, the second carbon, and the third carbon. So because there's 2 different versions here, I should mention this. These are isomers of each other. Same formula, but drawn differently. So sorry, I interjected that point there, but we just need to put a number in front of our name. So for this one here, it's in the 1 spot, so we'll put 1 dash propanol. And then here for the second one, it's on the second carbon. So this one here would be 2 propanol. And you can't have a 3 propanol because that would be the same as 1. It would just be flipped over. So you got lots of isomers here. When you got up to butane, just thinking you could have a 1 butanol and a 2 butanol. When you got to the pentanols, you could have a 1 pentanol, a 2 pentanol, and a 3 pentanol. There's a bunch of different isomers there. So that's about it. I mean, the only thing else we could kind of throw in to make this a little more difficult would be to throw like a methyl substituent on somewhere. So if I said draw the following, this is again about as difficult as they get. What if I said draw 2 methyl 3 pentanol? As hard as they get. What's going on there? Anyone else hear that? What's that? All right, how the heck are we going to do this one? Okay, well, start with the pentane. That's 5. Done. The OL tells us we have an alcohol, which is an OH group, and the 3 tells us that it's on the 3rd carbon. OH means alcohol. Yeah, and Alexis can't find the meeting. Okay, so hopefully you got it that far. Where'd the cursor go? And our next thing here is we need a methyl group on the second carbon. So, I don't know, I guess either side could be the second carbon at this point. So let's just go here. And that's our methyl group. And besides our hydrogens, that is all done. Draw the hydrogens in. Done. And that sort of wraps up alcohols. I don't know. Okay, maybe let's do one more after this, because I mean that was pretty fast. Let's just draw another one here. Any questions about that one? Cool. No questions means everybody gets it. Okay, let's do something crazy here. Let's do 2, 2 dimethyl dash, I don't know, 4 octanol. Oh, that's wonderful. Okay, so octanol, that would be 8. Like that. The OL ending tells us that we have an OH to put somewhere. It's on the 4th bond there. So let's see. 1, 2, 3, 4. Not the 4th bond, but the 4th carbon. Like so. And then we got some methyl groups on the 2nd carbon here. Like that. Done. Fill in the hydrogens. Finished. Okay, so that's all I have to say about alcohols. Let's talk about ethers. I like naming ethers. That's maybe the easiest one we're actually going to do. It's pretty easy. So let's transition to an ether. So here's what they contain. I probably should have put the word contain. Hang on. So they contain 2 carbon chains separated by an oxygen. So let's do some examples here. Like I said before, we're going to put an oxygen in between a couple of carbon chains. So I guess really the simplest carbon chains we could have would just be 1 carbon each. So I'll put a carbon on that side and a carbon on that side. And then again, we can't forget carbon always wants to have 4 bonds. So we need 3 and a 3. Now, here's why I like naming these ones, because all you do is you name the 2 groups and then you add the word ether because it's an ether. So in this first one here, oops, I mean that. In the first example here, we got a methyl group and a methyl group. So there's two methyl groups. So if we were to name this one, we would name it dimethyl, and no numbers are needed, ether. Dimethyl ether. The next most complex one would be a methyl group and an ethyl group. So again, you just identify the groups, and this one's going to be alphabetical order. So 2 carbons means we have an ethyl group. Yep, ethyl. And then that would be a methyl. So ethyl, methyl. And then that oxygen means that it's, an ether. So you add the word ether. Methyl ethyl ether. Might work best to put all on one line, but I ran out of space. Methyl ethyl ether. Maybe we'll do one more here. Methyl ethyl ether. Alphabetical order. Maybe make a note to yourself. Alpha order. What if we did this? And it goes so well, that one. Okay, so I didn't write out the full carbon chain there. I just squashed it together. So when we have 4 carbons, we're talking about a butyl. And butyl's alphabetically first. Butyl. Two carbons means we have an ethyl. No. Ethyl. Brought it back. And then that oxygen in between means we have an ether. Butyl ethyl ether. So there is a general formula for this. I haven't put it yet. I just wanted to put it underneath one of these ones here. Where your general formula, you do it like this. You put an R on one side and you put an R on the other side, but we use a little prime there. Okay, there's a little 1, and then that 1 just sort of stands. It could mean a different chain length. It could mean the same chain length as the other. If you look at the example above, our chain length was, that was meant to represent that. That was meant to represent that. That's our general form. Now, by the way, we're going to have, in addition to the all the hydrocarbons are done, we're going to end up having 8 molecules in the end. So on our Wednesday, we're going to make a nice review table where we put all this into perspective, and we're going to be able to use that table when we get into our test on the Thursday there, okay? So I said before, this isn't going to be like an open notebook thing, but that one piece of paper is going to have absolutely everything on it, so don't panic. We'll have everything we're going to need. One of the columns is general formula on there. Now, this is done. There's a however, though. Unfortunately, there's also a second naming convention for these ethers that's going to come up. So we've got to draw a line here. And I would love to have stopped at that. That would have been good for me. However, like I said, you're going to come across sort of a second way of naming this. So let's call this the alternative naming. It's okay, this one. It's not quite as catchy. So what happens with this one is you look at the molecule given and you put the short name first. So short chain goes first. Then the word oxy for oxygen, and then the long chain. So short chain, the word oxy, long chain. So I don't know. I mean, if you even look up here for the one we named on the top of this slide, right? This butyl ethyl ether, which to me sounds beautiful. But the way we would name this one would be we'd take the short chain, which would be the ethyl. Then we'd write the word oxy. And then the longer chain would be the butyl, but we don't say butyl, we say butane. I don't like that naming convention, but like it's going to happen here. We're just going to see it once in a while in our note today. So make note that the oxy is the ether part. If I were you guys, I'd stick with butyl ethyl ether. But ethyl ox, that doesn't sound right. Ethyl oxybutane. Hopefully, and again, I mean, if you see that name, that kind of reminds you, I would hope. You see the ethyl, you're like, okay, I know what an ethyl is. Oxygen, oxy, okay. And then butane. You just drop 4 carbons and bond everything together. So that wraps it. Oh, look at that. 2:35. Just in time for appointment. So I do have 2 teaching videos. Here was one I made on alcohols. So if you want to rewatch that, that's fine. And then here is one. This one's even a little like this. We got oxy. They used oxy for this one. So here's the worksheet, and I do have the answers. So it probably won't take it too long. Again, you're going to be flipping back and forth. I know we're learning 2 naming conventions at the same time. So here's a little table for you. So you've got the drawing, and then you can classify it. Or there's the name. So there's sort of 3 columns here. So kind of get used to doing this style. I drew this one, or this one I got was just lines. And instead of the lines here, kids, remember these are carbons. So there's a carbon there and a carbon on the end. Carbon, carbon, carbon. So this side has 3 carbons. This one only has 2. And then again, this is just sort of a common way. I don't usually do them like this. I'd rather draw out the carbons. But if you look around on the internet, this is a common way of doing it. They just draw the lines to represent the carbons. So there you go. Okay, so with that, you guys can